Looking at how we actually take samples. So we've talked about what a sample is. Now we're going to talk about how to actually take samples. One thing I want to point out is there is no perfect sample. Some are a little bit better than others, but there is no perfect, totally representative sample that exists in the world. Our job is to take ones as best as we possibly can, but there's no perfect one. I also want to point out that when we talk about these, there's also no perfect way to take any of these. These are what we strive for, but they may not be perfect and exactly what we think they're going to be. We're hoping to strive for them. We will work towards making sure these happen, but realize that they're not going to be perfect. So the first one, which is the one we actually try to head for and always like, is a simple random sample. And a simple random sample is where every unit of observation is um is likely or has the same chance, I should say that way, has the same chance of being in the sample. The other thing is that every sample has the same chance of being chosen. And that sounds kind of like, wow, what do you mean by that? But it really just means that I could have a sample here that picks these five objects, and I could have another sample that picks five different objects and five different objects, and keep doing that and picking those. And every unit of observation I could possibly ever have in the sample has the same chance of being in those samples, and every single one of those samples has the same chance of being chosen. So they each one I could have picked this one here, I could have picked this one here. They all have the exact same chance of being chosen. The way we actually do this is there's the best way to do this is to kind of put your values, your units of observations in a hat and pick names out of a hat or pick objects out of a hat. You wouldn't actually put the numbers in because if you had all the numbers for the whole population in a hat, then you already actually have the sample, I mean the census, and you wouldn't need to take a sample. So I wouldn't say take every value and throw it in a hat, but I take every unit of observation, give it a name, give it a something, put them in the hat, and then pick them from the hat. Now, we have to be careful because the hats could have problems. So we want to make sure that the hat's not going to be so big that you can't actually do this. So what we do instead is we give each unit of observation a number, and then we randomly pick those numbers. So you could randomly pick those numbers from a hat, or you could use a random number table to where you actually could randomly pick numbers from the random number table. You can also use a random number generator. They are not actually perfect. They actually have some issues with creating being random, but in this day and age, most people end up using a random number table, a random number generator to do that. Um, and that's really the gold standard where we try to go to. Unfortunately, it's really hard to get it because you have to be able to get every unit of observation name. If I was going to pick the houses of every house in Flagstaff and want to find the prices of their houses, I would have to find every single house in Flagstaff to give it a number. Now, that's actually not that hard to do because there is in the the recorder's office, there is every single house is actually listed. So we could actually get that list, but it might take a little bit of work to get that. If I want to ask every person in Flagstaff a question, getting the names of every person who's in Flagstaff, that gets to be a little bit more difficult. So getting that list is not going to be perfect. And that's why getting these are not always going to be chance to happen. Sometimes we don't always want to have just a simple random sample. Sometimes we want to have what we call a stratified sample, where we're going to look at just different groupings. So, as an example, if I want to take a sample of people and ask them what kind of music they like, that if I asked people in their teens as opposed to people in their 60s, I would get very different answers. So I wouldn't necessarily want to have a random sample of all of these people. I might instead want to take what we call a stratified sample, where I take and put the different individuals into groups and then pick from those groups. So we call those groups strata. So where you separate the unit of observations into distinct groupings called strata, and then randomly select inside each strata. So sometimes it's actually called a stratified random sample because you're still doing a random sample inside each strata, but you actually have separated them into these different strata. So you'd have a grouping of teenagers and 20-year-olds and 30-year-olds and 40-year-olds and 50-year-olds and 60-year-olds, and then you take random samples of the same size inside of each of those strata. So that would be a stratified sample. It's still a stratified random sample, but you've divided them into these strata. Another type of sample that we would have is what we call a cluster sample. And the cluster sample, you divide your unit of observations into groups again. Um, and then you randomly select the the groups. And we call those groups, I should actually call this, but we call those groups clusters. And then you randomly select the clusters you're going to use. And then you go in each cluster and collect data from every, we'll do it even more exact, from every unit of observation in each cluster. These are used an awful lot when we've got neighborhoods. So you might divide a city into neighborhoods, and then you go into each neighborhood and you pick which neighborhood you want to do, and then you go to every house in that neighborhood. Um, the reason for this is that it costs a little bit less money to just go into that one neighborhood and then walk that one neighborhood than to do a random sample where you have to drive all over the city. Another example of this would be if you took the Cook National Forest and divided it into sections or clusters, and then you went in and randomly picked clusters, and then you went into those clusters and looked at the diameter breast height of every single tree in that cluster. That would take a lot less time. You wouldn't have to walk all over the forest. You could just go into one spot in the forest. That makes it a little bit easier. The difference between a cluster sample and a stratified sample is a stratified sample uses every single strata and then randomly selects inside each strata. And a cluster sample will use some of the clusters and then randomly select inside the clusters. So if you were thinking of doing a stratified sample of the Coconut National Forest, you would use every single solitary piece of the Coconut National Forest and then every single strata inside there. And then you would just randomly pick trees in that strata. Um, if I were to do a cluster of that, is I would randomly pick which clusters I'd have to go to in the forest and then take measure every single tree in that cluster. So that's kind of the difference between those two. Um, Cluster samples are used mostly to make it so you don't have to walk as far and you can get some information. Of course, the problem is if you went into Coconut National Forest and were looking to see how many bark beetle damaged trees there are, if you pick clusters, you might have gotten a cluster that has a bunch of bark beetle trees and not really get an idea of how much is actually out there. The problem with stratified samples is if I go into a neighborhood and ask their opinion, a lot of times neighborhoods have similar opinions about different topics. So there are different reasons not to either one, but they do make life a little bit easier to do it that way. A systematic sample is one that's used in businesses an awful lot. And a systematic sample is where you randomly pick your starting point. And this is important to do because if you don't randomly pick your starting point, then everybody would have the same systematic sample. So you want to make sure you randomly pick your starting point first. Then you pick every kth item. So you might pick every 10th bottle on an assembly line, or you might pick every 100th car coming off an assembly line, or you might pick every 20th person walking by you. Before 9/11, they used to do systematic samples at airport security sometimes. Not that they wouldn't also just check people that they wanted to check, but they also may just systematically pick a certain people to do. So that's when we do systematic. We use these a lot in quality control, and so that's where you would see those. The last one is known as a convenience sample. These are the worst type of samples you probably should never do. And a convenience sample is where you take a sample that is easy or convenient for the person. These sometimes happen. Whoops, I can't spell. These sometimes happen where we do these, but they are not the best kind of sample to take. I could take a convenient sample of asking political questions of all of my friends, but most of my friends feel the same way I do, so that would be not a very good scientific survey. So I wouldn't want to do that kind of sample. And those are the different types of samples. There are way more samples than these. These are the main ones we're going to talk about, but do realize that there's a whole courses in sampling.